Before we go into 10.4, you should actually have a look at 10.3.2, which tells you the formal definition of what it is to calculate the directional derivative. You can therefore write definition of a directional derivative is very similar to partial derivatives and to the way that we define a derivative from first principles. But now we need key ingredients such as the unit vector, let's say components a and b, for a specific function that is a function of x and y. We'll see how we can generalize this to even higher dimensions. But for a function f of xy, if we want to calculate the directional derivative along a direction given by the unit vector u, ab, we write it, and this is the convention. I'll show you other ways of writing it. It's the directional derivative along the unit vector u of f xy will be given as the limit when h goes to 0. This should be familiar to you already. The big difference is we're looking at f of x plus ah, and this component is crucial. This is telling you how you're varying x. And the other component is y plus bh. And then we're subtracting, which conveniently sits here, f of xy, and we're dividing by h. This is a definition of directional derivative, in which you could say directional derivatives from first principles. The problem here is if you talk with your past self that was starting physics 101, that sometimes was struggling to take limits of functions of just one dimension. Remember when you're taking limits of things which were just a function of x? That can already be quite complicated. This is the reason why we derive differentiation rules, so we don't have to calculate the limits. Now imagine that you actually had to do this every time you take a directional derivative. It would mean directional derivatives wouldn't really be used that much at all. Fortunately, when we move to section 10.4 on the next video, you'll see that there's actually a very neat, simple way to calculate directional derivatives that rely on you calculating partial derivatives and the unit vector u. So that's great news. You don't need to really be calculating these incredibly complicated limits. In principle, you could, and this is the formal definition of calculating directional derivatives, but you don't have to. And all you'll have to do is calculate partial derivatives and then be multiplying by these components. But let's show mathematically what we actually need and why it is valid.